তো শুনতে পাচ্ছ না? না, শুনতে পাচ্ছি না। হুম। ফটো কাউন্ট হলো। Hello student. Yesterday I discussed some problems in the lecture 1 about limit, continuity and differentiability. Some problems just I am discussing, briefly discussing this. This first question was let fx is defined in this way. When x lies between 0 to half, fx is x. When x is equal to half, fx is equal to 1. Now when x lies between half to 1, then fx is 1 minus x. Then find the existence of the continuity of x. So here we can draw that from 0 to half, fx is in this way, the curve is this fx, and from half to 1, fx again in this way, but if x is equal to half, fx is equal to 1. So here, so you can look this from the figure that f is not continuous, discontinuous at x is equal to half. So you can also take the limit, left hand limit and the right hand limit of fx, which is half and 1, and f half is also 1. So so you can look this. This is discontinuous, but here these are equal. These are equal, but this is not equal. So what is? These are discontinuous of first kind. first kind of discontinuous. Now the second question is that fx is defined as cos x when x greater than equal to 0 and minus cos x when x less than 0. So here again we have to verify the existence of continuity of f. So if we draw the diagram for x greater than equal to 0, then we have the curve. This curve is the cos x, fx is equal to cos x, and when fx is minus cos x, x less than 0, then the curve will be in this way. So you can watch this. This is not a continuous curve. There is a breaking at x equal to 0. So if the left hand limit of the fx is minus 1, right hand limit of the f is 1. So here these are not equal, the left hand and right hand limit. F is discontinuous but of second type. So second type of discontinuous of this problem. Now the third problem, you can use this. Function is defined from R to R by fx. When x less than 0, this is x square, and when x greater than equal to 0, this is x square plus 2x. We have to trace the continuity and differentiability both for the f. First you can trace the continuity. Take the left hand limit, this is 0, then the right hand limit also 0, and f0 is 0. So this is continuous at x equal to 0. But if you take the left hand derivative, this is you will get 0, but the right hand limit you will get 2. So left hand derivative, right hand derivative is not equal. So f is not differentiable at x equal to 0. Now the fourth problem, if fx plus y is equal to fx into fy, for all x and y, suppose that f3 is equal to 3, f0 is equal to 1, and first derivative of x at the point 0 is equal to 11, then find the first derivative of f at the point 3. So here you can look this, that first derivative of x at the point 0 is 11, so you can write down in this way, f0 is given 1, so first derivative of f at the point 3, you can write down in this way. Here I have used this, this is a given relation here for f3 plus h, f3 and fh, and this solve this problem. Now we have to find out the fifth problem, the value of limit mod of x minus x by 2x, but what? Mod of x always is equal to x when x greater than equal to 0, and minus x when x less than 0. So if we test the left hand limit, the left hand limit we will get minus 1 and the right hand limit we will get 0. So these are not equal. So the limiting value does not exist. In the lecture 2, I will discuss some problems. Here given the sixth problem, the value of alpha in Rolle's theorem where minus pi by 2 less than alpha less than pi by 2, and fx is equal to cos A. So is equal to the value of alpha is equal to what? Equal to what? We have to find out the value of the alpha. So we know the Rolle's theorem. Here given function is given that so given here that fx is equal to cos x. Now we have to find we have not to test that Rolle's theorem is applicable here or not. Just we have to apply the Rolle's theorem. So what we will have, we have to find out some value from minus pi by 2 to pi by 2, for which first derivative of x at the point alpha is equal to 0. So what we will have, first derivative of fx at the first derivative of fx is sin x minus sin x. Now if we put here, then this will be minus sin alpha equal to 0. So we will get that sin alpha is 0. So at which point alpha is 0, sin alpha is 0, at sin 0 degree, we have to take the value from minus pi by 2 pi by 2. So sin 0 gives us 0. So we will have alpha is equal to 0. So for alpha is equal to 0, the Rolle's theorem works in this function. So the value is alpha is equal to 0. Now we will go in seventh problem. Here again the problem related with differentiability. Given that fx equal to x square sine of 1 by x, when x not equal to 0 and 0 when x is equal to 0. So we have to check the differentiability at the point 0. Paste the differentiability at x is equal to 0. So what we have to do here, let's first we have to find out that f is continuous at 0 or not. So sin x is a bounded function. We know that sin whatever value of x, sin theta is always mod of sin theta is always less than equal to 1. So for all values of theta. So we don't need to find out more. The sine of 1 by x always will be lies between -1 to 1. Means it is bounded and have a finite value. But when we will find out the limiting value at the x equal to 0, when x tending to 0, then it will gives 0. I mean to say limit of fx when x tending to 0, this will be limit x tends to 0. I am considering both left hand limit and right hand limit, both are equal here. So x square sine of 1 by x. So we don't need to consider this function another way. We can take any value from -1 to 1. We are taking that sine 1 by x is equal to p, where p lies between 0 to sorry p lies between -1 to 1. So we can replace this in this way. Limit x tends to 0. Now you can treat p as a constant. It does not depend on the x further. It is a bounded function. So you can for all values of x, so you can bring out from this function. You can just consider the function x square. So it will be 0, and f0 is also given as 0. So it is continuous at 0. So f is continuous at x is equal to 0. Now, if we consider the left hand derivative of fx, left hand derivative of fx at the point 0, it will be limit h tends to 0 f minus h minus f0 by h. So what will be the value if h tends to 0? Here this will be, we will have to take this function h not equal to 0, just tending to 0. This will be h square minus h minus on the square of the minus is positive. So this is h square, and this will be sine of minus sine of 1 by h, and f0 is 0, f0 is 0, this will be 0 by h. So what we will have, limit h tends to 0, minus I am bringing front, this will be, and 1h will vanish, and this will be sine 1 by h by 1 by h. So it is a form of infinity by infinity form. If we will put L'Hospital's rule, form, if we will put L'Hospital's rule, then it will be give me h tends to 0. Here it will be sine 1 by h, this will be cos 1 by h into minus 1 by h square, and here it will be again minus 1 by h square. Since h is not equal to 0, this term will vanishes by L'Hospital's rule, taking the derivative of the numerator and the denominator by L'Hospital's rule. So, and these will vanish. So what we will have, cos 1 by h you can look there, this will be limit h tends to 0, cos of 1 by h. So its value we cannot find out for cos infinity. This cos is bounded function, but it cannot be equal to 0. You can say that, one can say that this is not equal to 0. Any value can be, but one can say that this is not equal to 0. So the left hand limit you are finding this, the right hand limit also will be same, but there will not be a negative sign, and we will find out same. Similarly, if first derivative of 0, this is also not equal to 0. So what we have to say, that you cannot say that this is equal. These are not equal to 0, but this you cannot properly say that left hand derivative and the right hand derivative are equal. You can say not equal, and both have different values. Uh, Both have different values. Both can have different values. That's why you cannot say that f is not differentiable at 0. I mean that if it is not if it is not differentiable, this does not exist. You can say any one does not exist, and the right hand also does not exist. The limit does not exist. This also does not exist. So if is not uh, differentiable at the point G, continuous but not differentiable. X is equal to 0. Let's see another problem. The eighth problem.
Aduh,